Alright, in this video we're going to look at finding the domain, range, and whether a relation is a function or not for relations given in graph form. So in our first example we have a set of 4 points. There doesn't necessarily have to be an obvious pattern to a relation. Anything can be connected for some reason. The reason may not be obvious. But the domain and range is, the domain is all the inputs. So which values of x are being used? There's a point at 1, x equals 2, x equals 3, x equals 4. So that's our domain. For our range, we have output values, in this case y values of 10. A y value of 10 is being used twice. A y value of 20 for this point, and a y value of, let's say that's 25 for that. And is this a function or not? Each input has only one output. So 1's associated with 20, 2 is associated with 10, 3 is associated with 10, etc. So yes, it's a function. Okay, in this relation we have an infinite number of points, and we know that because we have this solid line which is made up of an endless number of points. Okay. So the question is, which values of x are being used? Well, if I take any x value, there's an x value being used here. This is the point 1 comma something, let's say. This is 2 comma something. This is 3 comma something. If I keep going in either direction, even over here, -5, is it being used? Go down to where it hits the graph. Yeah. There's a point on the graph with a -5 x coordinate. And because there's arrows on the end, this pattern is going on in all directions. So which values of x are being used? All values of x are being used for this relation. And the way we say that is x is an element of any real number. And so every value is being used as the domain of this relation. The range, well, similarly for the range, if I take any y value, so for example, let's suppose that this is y equals 10. Is there a point on the graph with a y value of 10? If I go over here, right here, that's something comma 10. Here's something comma 4, let's say. Is there a y value of 0 on the graph? Yeah, here's something comma 0. What about -10? Yeah, if I go over here to where the graph meets, there's going to be a y value of -10. So which y values are being used? Every y value. And is this a function? Pick any x value you want, go up to where the point is on the graph, and there will be only one y value associated with that. So yes, it is a function. Okay, a similar example, although our line doesn't extend endlessly towards the left. The domain. Which values of x are being used? Okay, well you'll notice that the first x value that's used is right here at x equals 0. -1, there's no point on the graph above or below where x equals -1 is being used. So the x values being used are 0 and higher. X equals 1 is being used there. X equals 2 is being used there. X equals 1/2 is being used there because all the points are included. Alright, so we're going to say x is 0 or bigger, including 0. So that's x is greater than or equal to 0, where x is a real number. So we're saying any real number as long as that number is 0 or greater. By real number, remember, we mean all numbers, decimals, fractions, all the numbers bigger than 0. For range, which values of y are being used? Okay, so if you pick a y value, the first y value that's being used is 10. Okay, and then 20 and 30. But all the values in between, 25, 21.5, all of those are being used. So y is greater than or equal to 10, where y is a real number. And is this a function? Does each x value match only one y value? So when x is 2, we have this y value. When x is 3, we have this y value. Does each x have one y value? Yes. So yes, it is a function. And since it's a function, we could use function notation to represent this function. Now what you see over here is y equals f of x. That's just saying that there's a connection between x and y. F is the name of the relationship between it. You're taking x and you're associating it with y. Now just on the topic of is something a function or not, what we often use is something called a vertical line. And if you can take your vertical line and move it over the graph so that this vertical line intersects your graph in only one spot, that will mean that your relation is a function. Because for a given x, there's one y. In my next example, I'll notice that I don't have a function, because if I take my vertical line, for example there, I can see that I have an x input of 1 and an output of 10, but I also have an input of 1 and an output of 20. So each x is not used once. Alright? And we sometimes say that our graph fails the vertical line test. Our vertical line hits the graph in more than one spot, which means it is not a function. Alright? Still has a domain and range though. Every relation has a domain and range. Now my domain values, let's just move our vertical line out of the way here. Our domain goes from an x value of 0, because x equals 0 is being used on this point, up to x equals 2, which is being used on that point. And all x values in between, like a half, are being used as well, in fact in two spots. Alright? So our domain is x is between and including 0 and 2. That's how you would write your domain in words. But we'd like to use a symbol. And so a nice way to say all of that together is to say that x is less than, but it's also equal to 2. I know it's equal to 2 because the solid dot means that 2 is part of my graph. But it's bigger than or equal to 0. And the way you literally say this is x is between and including 0 and 2. If you were to pop a number in your domain into that spot, such as 1, you'll see that 1 is smaller than or equal to 2 at the same time as it's bigger or equal to 0. Your range, the y values that are being used, between 20 and 10 inclusive. So y is between 20 and 10 with equal signs on those symbols where y is a real number. And as we said, it is not a function.